Particulate matter equal or smaller than 2.5 micron or PM2.5 is the main component of air pollution. Due to its small size, PM2.5 have been shown to penetrate the blood-brain barrier, posing as a risk for neurodegenerative diseases. In vitro studies have shown that PM2.5 can cause oxidative stress, increase inflammation, and decrease cell viability in neuronal models. Here, we were interested in further investigating this phenomenon using shy-Y neurons. To do so, shy-Y cells were exposed for 24 hours to PM2.5 at different concentrations, ranging from 20 to 300 microgram per ml. An XCT assay was then performed to assess cell viability, where we can see in Figure 3 that the 300 microgram per ml dose of PM2.5 had a statistically significant decrease in cell viability when compared to untreated cells. In addition, to study the effects of sublethal PM2.5 exposure on inflammation, shy-Y cells were once again exposed for 24 hours at a dosage of 100 microgram per ml of PM2.5. The cells were used for reverse transcriptase quantitative PCR, RTQ-PCR, looking into TNF-alpha gene expression. And as it can be seen on Figure 1, the TNF-alpha gene expression on exposed cells was not statistically different from the untreated cells. Furthermore, the media in which the shy-Y cells were grown was collected and used for an ELISA protocol, looking into the release of TNF-alpha. When we look into Figure 2, we can see that unexposed cells had so little TNF-alpha secretion that it was out of the limit of detection, explaining the negative values obtained. Although the release of TNF-alpha by treated cells was not significant when compared to control, a trend towards a small increase of TNF-alpha release following exposure to PM2.5 for 24 hours can be seen. In conclusion, we found a significant decrease in cell viability following 24 hours exposure to the 300 microgram per ml dose of PM2.5. This suggests that higher doses of this toxin are capable of leading to cytotoxicity. Considering the trend towards increased TNF-alpha release at the dose studied, combined with the differing effects on viability between 100 and 300 micrograms per ml PM2.5, it is possible that a higher dose may have elicited a significant inflammatory response. Establishing this would prove valuable to future application of this model to study the neurotoxic effects of air pollution. Here, we found that exposure to 100 microgram per ml PM2.5 did not lead to a significant increase in TNF-alpha gene expression nor its release, although a trend towards a higher TNF-alpha concentration was noted in the exposed group. TNF-alpha release in untreated cells was below the limit of detection, leading to negative numbers. Therefore, further research is needed to explore if longer exposure times and higher doses of PM2.5 would produce different results in terms of inflammatory response. In addition, using differentiated shy-Y cells may also lead to higher cell susceptibility. Moreover, expanding the dose range between 100 and 300 microgram per ml PM2.5 would be interesting to more intricately examine the cell viability response. Thank you.